Hi everyone. We've made a lot of progress since our last video. We've got Mack's arm attached to the torso. We built the torso. We have several servo boards or servos that we've installed, servo board cards, Arduino and whatnot that we put in here, and I'll talk about a little bit of that a little bit more later on. We've also added a bunch of 3D printed parts, heavy duty parts, and we'll talk about that a little bit more too. But first, let's just see what Mack can do. Let's do a little demo here. Showing his flexibility. He's got a lot of good wrist movement and his signature moves with his fingers. Going up for a big high five. Got a lot of flexibility, pretty much can mimic all the flexing movement of your regular, of your arm, and a good nice muscle move. And possibly maybe even a little bit more movement than that. So he's very flexible, can do pretty much anything with his right arm that you can. So let's talk about what we did here a little bit. First thing that we did is we moved the servo boards that I had in the hand and the forearm. We moved it up here and put in a 24 port servo card. I used a Cat 5, I had some patch cables, some Cat 5 patch cables that I had stripped down and pulled the wires out, and that's what I used here. It actually worked really well for the signals. So I ran that for the signals, and then I ran a 16 gauge wire to directly for the power to all the servos. So what that did was eliminated me running the power for all the servos all the way back up to the board, and eliminating a lot of weight, extra wire, and bulk in this area. So that worked out really well, and controls everything with one servo card versus two servo cards. So I like that. I duplicated over here, so we're going to have one for the right arm, which controls basically from here over, and then one for the left arm. We also have a 24 port card, servo card, controlling the bottom half. So basically from the hip down, so both legs and the hip. I have a couple servos up here that are dual. Up here in the shoulder, in the up and down, and then the this is the up down, and then this is actually in and out. These servos are running simultaneously. They're 35 kg servos, so with two servos you're running at about 70 kg, plus I'm running 2.3 to 1 gear ratio, so we've actually got quite a bit of torque for lifting the arm. We're not gonna be lifting 150 pounds or whatever, but he's still got pretty good. I don't know what the exact limit lift, but I'm not worried about that. That's not an issue. Main concern here is just functionality and getting him to operate with what we need. So the other thing is these two sets of servos are running the same direction, so I don't need this little added reverse signal controller, which I need on this side because I have a servo on each side, so they're actually running in opposite directions. So to get them both going in the same direction, I have to run a reverse signal controller. So that's what this does over here. Don't need it over here, but I also need one down here on the torso, which is going up and down, side to side, and then twisting. So that's what we have right here. Also have the Arduino Uno 4 board and the Raspberry Pi 5 board that I've installed, but I don't have those hooked up right at the moment, and that's something that we're going to get into down the road in our next videos. But basically, that's going to be the heart of a Mack. It's going to basically control everything, including his head, which is going to have like cameras, and we're also going to have microphones and speakers and whatnot in there, and so on. So anyway, that's down the road here. First, we just got to get him built. So our next move is to get the left arm installed and the hip plate, and so that we can get his hips moving, you know, side to side, up and down, left, right, all that. So let me rotate him around here, and I'll show you what I actually did on the back side. So I had to install a voltage regulator. I'm running at 7.5 volts, which is needed for these particular servos to get the maximum torque. That's what the voltage rating is. I'm also going to install a additional voltage regulator over here for 5 volts, which is going to operate the Arduino board and the Raspberry Pi, and any other lower voltage things that I might have on there. So this is the 18 board servo that is controlling the head and the neck area. So that'll drive all the servos up in the head and the neck. So these particular parts that I 3D printed, I changed out to the PETG. When I first started printing some of this, I was using the PLA. Changed to the PETG, and I'm really glad I did. It took a little bit of testing on a few parts to get the stringing, because it strings a little bit, but got that under control. I'm really happy with the PETG. It prints really well, and it offers much better post machining. In other words, drilling and tapping of holes and things like that is much better. So these parts are, most of these parts I did 100% density on, because I wanted the strength and whatnot in them, including the gears. So all these gears in here, these are all 100% density PETG parts. However, with that said, I did have a few of these in the arm. In the original arm, I had the PLA gears, which I accidentally crashed Mack. I was doing some programming, and I have the arm at his home position is right here, and I had his arm up like this, and I'm telling Mack, well, okay, you know, go home, go to your home position. Well, when he did, he tried to go through the body and over to here to home. And when it did, it went right through this area right here and ended up crashing, and it broke that gear, both of these gears here and both of these gears up here. So I had to replace 4 gears. They were the PLA. They were kind of weak to begin with. So I replaced them with the PETG, which is much stronger. However, with that said, if you want to break something, that's what I actually want to break, and that should be our weak point here, is those gears. And if we do crash, it's easy to replace the gears, so that's a good thing. So one of the other things that I did want to talk about is the body, the torso. I ended up actually choosing a piece of oak, and it's solid hardwood oak. It actually worked out really well. It's lightweight, 3/4 inches thick. It actually, you can drill and tap it really actually pretty good. If you do that, I suggest that you tap whatever the tap size that you're using and the recommended drill bit, go about 10 thousandths under, and it actually holds a screw really well. So that actually worked out quite well. The weight that we ended up with Mack at 10.9 pounds. So that's really, really good. And that's my goal, is to try to keep him as light as possible. And that's basically what we're trying to achieve here. And I think we're doing a pretty good job at that. So with the minimizing our use and the size of the servos, going with the oak instead of like aluminum body, which I originally had planned, but trying to reduce that weight, this really works out well. So I think let's do one more demo and then see where we're at. And one of the things that, you know, as we go along with, and this is all in the programming, you can smooth out the arm movements, and so that they're not so rigid, so to speak, and jerky. It can also be, you can speed them up. I've got them slowed. The servos are going really slow right now, but they can actually go very fast. So he's in a kind of in a slow motion move right now. The outside skin layer, so to speak, we'll be putting on and adding down the road. The back side of his hand, I've actually printed one of them, and using a clear plastic PLA, so that's a good use of the PLA. That's the back side here. But I think that's probably it. I'm gonna get busy doing the left arm and this hip piece down here, and we'll see you on the next video.